Let's take a closer look at what really holds your plastic parts together: ribs and bosses. These features might seem small or insignificant at first glance, but they play a massive role in the strength and durability of almost every plastic product you use. They're not just random bumps and ridges. They're the hidden backbone and silent supporters of every sturdy plastic product, working behind the scenes to keep everything intact. Without these internal supports, your favorite gadgets would be flimsy, weak, and likely to fall apart after just a little use. Take a look inside a remote control or a drone shell. Those thin walls and little towers you see, those are ribs and bosses, quietly doing their job. They add crucial strength and provide connection points for screws and fasteners, all while keeping the part lightweight and easy to manufacture. Mastering the design of ribs and bosses is what truly separates a good designer from a great one in the world of plastic engineering. It's not just about following a set of rules. It's about understanding the reasons those rules exist and how they impact the final product's performance. When you understand the why behind these features, you can make smarter choices and create parts that are not only strong, but also more reliable and longer lasting. So, let's break down the process and learn how to design these essential features like a true professional, ensuring your plastic parts stand the test of time. So, what's a rib? In plastic part design, ribs are one of the most important features for adding strength without adding unnecessary weight or bulk. Think of it as the I-beam of plastic parts: thin, strong, and efficient. Just like an I-beam supports a building with minimal material, ribs reinforce plastic parts while keeping them lightweight. Instead of using thick, heavy walls that waste material and increase cost, ribs reinforce large surfaces with minimal material, making the part both stronger and lighter. They boost stiffness, prevent warping, and keep parts light. This means your parts stay rigid and durable, even under stress, without becoming bulky. Key rules. Rib thickness should be about 50–60% of the main wall to avoid sink marks. If ribs are too thick, you'll see ugly surface defects and weak spots. Height? No more than 3 times the wall thickness, or you risk weak, hard-to-mold features. Tall, skinny ribs can break or cause molding problems. Always add a draft angle, about 0.5 to 1 degree per side, so the part pops out of the mold cleanly. Without draft, parts can stick and get damaged during ejection. Space ribs at least 2 to 3 times the wall thickness apart to avoid molding issues. Crowded ribs can trap material and cause defects. And don't forget a small fillet at the base, about 0.25 times the wall thickness, to prevent cracks. Sharp corners can lead to stress concentrations and early failure. Smart rib design means strong, lightweight, and manufacturable parts. It's the secret to making your designs both efficient and professional. That's how you get pro-level results. Parts that look great, perform well, and are easy to manufacture. Let's move on to bosses, another key feature in plastic design. If ribs are the skeleton of a plastic part, providing internal support and structure, then bosses are the joints, those hollow cylinders where screws bite in, or where parts come together and align perfectly. Bosses anchor fasteners and help align assemblies, making complex builds and precise fits possible in plastic products. For strength and to avoid cosmetic defects, keep boss wall thickness around 60% of the main wall. Making them thicker can cause sink marks and warping, which weakens the part and looks bad. Boss height is also critical, never more than 3 times its outer diameter. Taller bosses become weak, prone to bending, and are difficult to mold without defects. If you need more strength, don't just make the boss thicker. Instead, add support ribs or gussets. These reinforcements boost strength without causing molding issues. Always use a draft angle, at least 0.5 degrees inside and out, so the boss releases easily from the mold, preventing damage and ensuring smooth production. Add a generous fillet at the base of the boss. This rounded transition spreads out stress, prevents cracks, and increases the part's durability. Well-designed bosses mean reliable, robust connections that stand up to repeated use and assembly, ensuring your product lasts. Now, let's look at how to avoid the most common mistakes in boss design, so your parts are strong, reliable, and easy to manufacture. Here's what to do. Don't make features too thick. Thick ribs and bosses cause sink marks and slow cooling. Never skip the draft angle. Vertical walls stick in the mold and cause defects. Avoid sharp internal corners. Stress concentrates there and leads to cracks. Always add a fillet where features meet walls. Don't make ribs or bosses too tall or pack them too close. They'll be weak and hard to mold. Give the mold room to breathe. Space features out and keep them within recommended proportions. Think manufacturability at every step. These small details prevent big headaches. Now, let's see how these rules pay off. Mastering ribs and bosses isn't just about rules. It's about building smarter. Good design means parts that mold easily, cost less, and last longer. Proper ribs and bosses make parts strong, light and reliable. No sink marks, no cracks. You save time, money, and avoid production headaches. These features turn ideas into real, robust products. Next time you design, think about the flow of plastic and the forces at play. Build with purpose and your parts will work and last. Now go build something awesome.